All right, y'all. So 9.6, solving equations. Y'all let me let two in real quick. All right, so 9.6, solving equations. All right, y'all. So we'll start out solving exponential equations, and then we'll end up solving logarithmic equations. So we're going to start out with solving exponential equations. And y'all, exponential equations look like this. Y equals A to the X. Remember, A is the base, X is the exponent. But in these equations, we're solving for X, which is going to be the exponent, okay? So the steps to solving, I'll write those and then we'll play with some equations. Hey, y'all, so the first thing, if possible, rewrite each side of the equation using the same base. Okay, so if I got something like 2 to the x equals 8, I'm going to try to rewrite the 8 with a base of 2 raised to an exponent. And y'all, I'll show y'all that when we get to a problem. But the reason I try to rewrite them with the same base is because we got what we call a base exponent property. And this base exponent property says if a to the x equals a to the y. Notice they got the same bases on either side of the equal signs. So if these bases match up, then that means x has to equal y. The exponents have to be equal if two sides are equal and they have the same base, okay? So that's the first thing I try to rewrite them if I can. Um, so if it's not possible, So if it's not possible to rewrite using the same base, then we got to go another route to solve for this exponent, okay? So that would mean what I would do in that case is I would take the log or the ln of both sides. So because when I take the log of a side, I can use the power rule. So using the power rule, I can bring the exponents down and rewrite it as a product. And y'all, that goes back to that little property where we had so we had something like this: log base A of B to the C. This property is one where we brought the exponents down to the front and we wrote it as C times log A of B. That's what we're talking about using this power rule, bringing the exponents down and writing them as a product, okay? Okay, so at that point, no matter if we rewrote each side or we had to take the logs or the LNs of both sides, at that point, we're going to solve for the variable. And then finally, like any equations, check your answers if needed. And you ought to check answers. I'm just going to plug stuff back into the equation and see if it's true if you need to do that, okay? All right, so my steps. I'm going to start out trying to rewrite each side if I can. If I cannot do that, I'm going to take a log or ln. I'll take a log if it's a number for the base. I'll take an ln if it has the little e for the base, okay? All right, that's going to give me the opportunity to bring the exponent down, write it as a product. At that point, we'll solve for the variable and then check if needed, okay? So all of these will be exponential until I get into the instructions for doing the logarithmic type. So these examples are going to say solve for x. And also number one is 6 to the x equals 36. And we'll bring my chat up. So the first thing I'm looking at, can I rewrite each side using the same base? So since the base over here is a 6 raised to the exponent of x, can I rewrite 36 as 6 raised to an exponent? So Justin says yes, and that's true on this one. I can rewrite 36, so I can rewrite 36 as 6 squared. Right? 6 times 6 is 36. So I can rewrite it as 6 squared. So that's going to let me write this as 6 to the x equals 6 squared. All right, so at that point, my bases match. So y'all notice, my bases match. So since my bases match, I'm going to invoke the base exponent property, which says if these bases match, then these exponents got to be equal, which means x has to equal 2. All right, y'all, let's see if I put a 2 in here. 6 squared equals 36 is true. So I know that 2 is my answer. All right, y'all. So that's how you're going to do this. Let me let one in real quick. All right, so let's try this number 2. I got 4 to the 5x equals 16. All right, so my first step, can I rewrite each side of this using the same base? So over here, I got a base of 4 raised to the 5x. So is it possible to rewrite 16 as a base 4 raised to an exponent? And y'all, that's going to be true, right? So what I'm going to do, rewrite 16 as 4 squared. Okay? And that's a trick on it. See if you can rewrite the number with the same base as your exponential side, okay? All right, so that means since I can rewrite 16 as 4 squared, I'm going to bring down 4 to the 5x. That's going to equal 4 squared. So notice the bases match again. So since we got our bases to match, that means the exponents have to be equal. So 5x has to equal 2. So this one, I was done because I didn't have no work to do on this one. But y'all, this one, I can go further because I can solve this for the x. And y'all, to solve that for the x, we simply divide both sides by the 5. So that cancels, giving me a 1x. And then, y'all, we can't do nothing to that. So that's going to stay 2/5. So if you're going to check this, I will take my 4 to the 5. In place of the x, I put the 2/5. And that's got to equal 16. Well, look here. The 5's cancel. So this ends up being 4 squared equals 16. And y'all, 4 times 4 is 16 equals 16. So that checks. Okay, so simply plug back in to check them if you want to, okay? All right, so notice, these were able to be rewritten with the same bases. So let's look at some of those where I couldn't rewrite them. So I'm going to do 5 to the x equals 24. And y'all notice on this one, I got a base 5 here. It's not possible to rewrite 24 with a base of 5 because 5 times 5 is 25. That's already too big, so I don't even need to check anything else. But I couldn't rewrite 24 using the 5s. So remember, I said if we couldn't rewrite them, then we got to take a log of both sides. So I'm going to take a log of both sides. So remember, you always got to do what you do to one side of an equation, you automatically do to the other side. So we're going to do this. We're going to do a log of 5 to the x equals a log of 24. Now remember, the whole reason we said we're doing this was I could rewrite this side as a product. So to do that, we're going to bring this x down to the front and rewrite it as x times log 5. That's going to equal this side, which is a log 24. So I got x times log 5. If I want to make that x be over there with a 1 in front of it, I'm going to divide by log 5. So you're going to bring down this x log 5, divide by a log 5. That's going to equal your log of 24 divided by log of 5. So y'all look here. These log 5s cancel, making that a 1x. Now, anytime you're taking logs of the numbers, we're going to use the squiggly equals because we're approximating the answers. And what they want us to do on these is round our answers off to 4 decimal places, okay? Now, I'll show you 2 ways to punch this on the calculator. So y'all let me go to the calculator and we'll see how to punch them in. So one way is I can make it look like a fraction by hitting alpha, y equals, and enter. On top, I'm going to put the log, and you're using the log over here by the 7, so hit log and put 24 in, close those parentheses. Arrow down to the bottom, you're going to put in a log 5, close parentheses. Now remember, we're going to round at 4 decimal places. So y'all, this will be 1.974. So I'm looking at the 6. The 6 has the 3 behind it, so we're going to leave that a 6. So I get a 1.9746. Now the other way is if you don't want to make it look like a fraction, you can do this. You can do log 24, close parentheses, and then divide by log 5, close parentheses. You got to close the parentheses on each log doing it this way, okay? And notice when I hit enter, I still get 1.9746. All right, y'all, and that's the trick on these is can I rewrite it or can I not, okay? So let's try this one. 3 to the 9x minus 5 equals 81. So let's ask each other, can we rewrite 81 as 3 raised to an exponent? Yeah, Justin, you're pretty quick on that. So let me ask y'all, what exponent would you raise a 3 to equal 81? And y'all just start well, it'll be 3 times 27, but what I want is how many threes altogether are you multiplying? So do like 3 times 3 is 9, that's 2 of them. 9 times 3 is 27, that'll be 3 of them. And then 27 times 3, and now you got it, yes, and it's 4, because 27 times 3 is 81. So that was multiplying 3 times itself 4 times. So we're going to do that. We're going to rewrite 81 as 3 to the 4th power. And y'all remember, 81 is 9 times 9, and each 9 has 2 threes in it. So altogether, that's 4 threes, right? All right, you also bring this down. 3 to the 9x minus 5 is going to equal 3 to the 4th. So that's nice because now these bases match. Since our bases match, 9x minus 5 has to equal that exponent of a 4. Okay? That makes sense. This has to be a 4 for this to be 3 to the 4th equals 81 and make that true, okay? So what you're going to do, you're just going to solve this. So to solve that for the x, we're going to start out by adding 5 to both sides. That gives me my 9x. Those cancel. 4 plus 5 is 9. And y'all look at that. Our final step, divide both sides by 9. So that cancels, giving me a 1x. 9 divided by 9 cancels, giving me a 1. That makes sense. If you put a 1 in there, 9 times 1 is 9. 9 minus 5 is 4. And 3 to the 4th equals 81. All right, y'all. So do y'all have any questions on these yet? Hey, y'all good? So let's continue on then. All right, so this one will be like number 5. 3 to the x equals 5. So we would ask ourselves, can we rewrite this one with the same base on each side? You got a base of 3 here and a base of 5 here. So good job, Justin. There's no way I can't turn this 5. There's nothing I can raise a 5 to equal a 3. So I cannot rewrite this one. So since I cannot rewrite it, I'm going to take a log of both sides. So that's going to give me a log of 3 to the x equals a log of 5. And you're going to notice when you cannot rewrite them using the same base, y'all, it's going to be log stuff all over the place, okay? So the reason we wanted to take a log of each side is so I can bring this exponent down. I can't solve for the exponent while it's up here like an exponent. So by taking the logs, we're using our power rule that says we can bring the exponent down front and rewrite this side as a product. X times log 3, that's going to equal the other side, which is a log 5. And y'all remember, log 3 is basically a number. So I got x times this number. I'm going to divide by this number on both sides to get that x by itself, okay? So you're going to have an x log 3 divided by log 3. That's going to equal this log 5 divided by log 3. So this cancels, leaving me my x. Now remember, since I got logs left, we're going to approximate this to 4 decimal places. Okay? So y'all, let's go to the calculator because those cannot be done by hand. You actually got to use a calculator for that log stuff, okay? So let's go see what we're going to get. I'm going to make mine look like a fraction by hitting the green alpha button, y equals, and enter. So on top I had a log 5, so that'll be log 5, close my parentheses, arrow down, and I had a log 3, so that'll be log 3, close parentheses. All right, y'all, that's what I need. So let's hit enter and estimate it 4 decimal places. So this will be a 1.46. Oh, look at that. I got a 4.9. But y'all, that 9 has a 7 after it. So I'm going to have to round the 9 up. But look at that. When you round that 9 up, that's going to cause the 4 to go up. Exactly. So that's going to be a 5, 0. So if you got a 49 and you're rounding it up, that becomes a 50. So Justin, you had that right. So good job. All right, y'all. So that's the trick on these. Can you rewrite it? Can you not? Okay. All right, what am I on? Number 6. So let me show you one where I would use the ln versus the log. So 6 has e to the t equals 153. Because this is nice when you got an E here and you do the LN stuff, you'll see some sort of magic happening on these. Well, the first thing, I'm not going to try to rewrite 153 using a base of E. There's no way you can do that, okay? So since I cannot rewrite both sides using the same base, on this one, I'm going to take LN of both sides.
3. Oh, that's a last.
Okay, so we'll take an LN of both sides. LN of E to the T will equal to LN of 153. Now, y'all, here's a nice property on this. Remember, LN is really a log base E. Okay, so ln is really a log base E. So this left side, you got a log base E of E to the T. So that's really what this ln of E to the T is. It's really a log base E of E to the T. And y'all, I had a property last week that said if I had a log of a base, well, if that base raised to an exponent, this whole thing equaled the exponent. That's what's nice about the LNs. When you take an ln of E to an exponent, in the long run, this side equals the exponent. So this property is big when you're dealing with the E's, okay? So that means this side equals nothing but a t, because if you bring the t down, you basically got a t times 1, which is t. So t is going to equal to ln of 153. Now remember, since that's a log I'm taking, I'm going to approximate this 4 decimal places. So let's go look at the calculator. All right, y'all, we got an ln right to the left of the 4, so hit ln, punch in your 153, and then hit enter. Now we're going 4 decimal places, so that'd be what, a 5 point, what we got, 0304. The 4 has a 3 after it, so I'm going to leave that a 4. So that'll be a 5.0304. And y'all, that's the trick on those exponentials. That's the whole trick. Can I rewrite it using the same base, or do I have to take those logs or LNs of both sides, okay? So notice, when I just had numbers over here, I took logs. Quick and easy. Now, you could have took LNs and got the same answer. But I really saved my LNs for the E, because when I take the ln of an E to an exponent, it always equals the exponent on those, okay? All right, y'all, so those were the exponentials. So now we're going to start solving logarithmic equations. So logarithmic equations look like this. Y equals a log base A of X. And then these will use some of those properties we used last week also. So y'all, the first thing, if needed, combine logs on each side. So combine logs on either side or both sides. So that means write each side as a single log. So what I mean is, if I have 2 logs being added, I can rewrite them as a product. Remember, we had a product rule of logarithms. So if they're being added, I can combine them as a single product. If they were being subtracted, I rewrote them as a single quotient. Okay? Remember, the positive factors went to the top of the fractions, and the ones being subtracted always went to the bottom of the fraction. So that's what I'm talking. I'm looking at either side of the equals to see if they have more than one log, okay? So at that point, I'm looking at a question. Do we have a log base equal to a log base? So this next little property is sort of similar to that base exponent property, where if I had the same bases on each side, we said the exponents were equal. Well, y'all, this is what we call logarithmic equality. It says if a log base A at M equals a log base A at N, So look, I got a log base A of M on one side equal to a log base N on the other side. If this log base is equal to this log base, then that means M has to equal N. And then we just solve it at that point. But we might not have a log base equal to a log base. So if not a log base equal to a log base, then we're going to rewrite it as exponential. And remember, to rewrite it as exponential, you're going to write the base, the exponent, and then that's going to equal the result. Now, y'all, let's see at that point. So let me just write this. Log base A of y equaled x if and only if A to the x equals y. So I'll use this conversion to rewrite these log equations as exponential, okay? And at this point, solve for the variable. And y'all, it is very important on the logarithmic equations. You gotta check if needed. And the main thing I'm checking for that we learned last week is that I cannot take logs of a negative number. Remember, we had some examples where you had to try to take the log of a negative 65 or something. Well, we got non-real results for those, right? So since we got non-real results when we try to take a log of a negative number, that means if we get negative answers, we got to throw them out. So throw out any negative answers. Okay. All right, so going through my steps. First thing, if I got more than one log on either side of the equals, I'm going to combine them into one single log using the product rule or the quotient rule of logarithms. At that point, I'm looking at it. Do I have a log base on one side equal to a log base on the other side? If I do, I'm going to invoke the logarithmic equality, which says if a log on one side is equal to a log on the other, then that means the result, m, has to equal the result, n. Well, if I don't have the log base equal to a log base, then I'm going to rewrite my logarithmic equation as an exponential equation using this type of conversion. All right, y'all, no matter which way I went, if I was able to do a log base or if I had to rewrite them at that point, I'm solving for the variable. And then I want to check answers because, like I said, I cannot keep negative answers, okay? Y'all, so let's start working our logarithmic ones. These will be the same way. They'll say solve for x. All right, y'all, so for number 7, they gave me a log base 4 of x equals 2. So I only got one log on this side, and this side does not even have a log. So I don't have any logs to combine. I don't have a log equal to a log because all that's over here is a 2. So I don't have a log base equal to a log base. So I'm going to have to go on down, and it says if I don't have a log base equal to a log base at this point, I'm going to rewrite this as exponential. Hey, that's the first thing I can do to this. Okay? So to rewrite it as exponential, I take the base of a 4, bring that down. The exponent for the 4 will be the 2. And this 4 squared has to equal that result of an x. So that's how they're going to look when you rewrite them as exponential. And y'all look at that. We've only got one thing we can do to this, and that's to figure out what 4 squared is. So y'all ask y'all, what is 4 squared going to give us? All right, so remember, that exponent 2 means you're just doing 4 times 4 twice. Justin, you got it. It is definitely 16 equal to my x. So if you put a 16 in here and did a log base 4 of 16 and spit it in your calculator, it would give you a 2, which is equal to a 2, okay? How about log x equals -5? I'm going to look at something where y'all write that and catch up with me real quick. Anyhow, so here we go. I don't have but one log on this side, no logs on that side, so I don't have no logs to combine. I don't have a log base equal to a log base because there's just a number over here. So remember, at this point, we're going to rewrite as exponential. All right, so, let me ask y'all this. Let me ask you this. This log does not have a base written by it. There's no subscript for a base on this one. So remember, if you got a log that does not have a base, remember this log is the same thing as a log base 10. Good job. So I just now seen you had a 10 up there. Good job. So that means I would have a base of 10 raised to an exponent of -5. That's going to equal my result of an x. And y'all, let me see how they write that answer real quick, because some of these they write as decimals. All right, so let me show you how you would write 10 to the -5th. That's going to be a point, and you would have 1, 2, 3. Oh, then what am I? My 1. So -5, it's be like moving the decimal left 1, 2, 3, 4, 5 times. So if you had a -3, you'd be like 1, 2, 3.001. So if you're at a -5, you'll have 4 zeros and a 1. -4 would be 3 zeros and a 1, and so forth. They're converting these negative exponents into decimal answers on that one. All right, y'all, let's try this. Log base 6 of 4x minus 4 equals 4. If you notice, I only got a single log over here. No logs on this side, so I can't combine any logs. I don't have a log base equal to a log base. So once again, we're going to rewrite as exponential. So this time I got a base of 6, an exponent of a 4, and that's going to equal 4x minus 4. All right, y'all, punch this on the calculator for us. 6 to the 4th power. And let's see what we get out of that, because that's going to be a big number. That'd be like 6 times 6 is 36. 36 times 6 is 2 something. So what do y'all got? 1296. Sounds good. That's going to equal 4x minus 4. And y'all notice, we're going to now solve for x. So we're going to add our 4 to both sides. Oh, y'all, let me see. That's going to give me even 1300 equal to my 4x. That cancels. All right, now get ready and divide 1300 by 4 for us. Because we're going to divide both sides by the 4. So y'all divide 1300 by 4, and what is that? 325 equal to my x. Ready, y'all? That'll be our final answer. So y'all ain't gonna lie, these 3, you had one step. Rewrite them as exponential and then start solving for the variable. So let's up it a little bit and get a little more into those steps I gave you. So for number 10, I'm going to do this. A log of x plus a log of x minus 21 is going to equal 2. Well, the very first step says, if needed, combine logs on either side of the equation. Well, I got 2 logs on the left side. I don't have any logs over here, but I got 2 over here. So what I got to do is combine these 2 logs into a single log. So I'm going to rewrite as a single log. Since these are being added, you would write it as a product of x times x minus 21. All of that equal to a 2. So if they're being added, you write them as a product being multiplied. And y'all, I'm actually going to go one step further and multiply this. Okay? So x times x is x squared. X times -21 is a -21x. All of that equal to 2. So I now have my product here from multiplying that x times that x minus 21. Now notice this. I don't have a log base equal to a log base because I don't have a log base on this side. So since I don't have a log base equal to a log base, at this point, we're going to rewrite as exponential. So you combine logs by writing it as a product. And then at that point, we're going to change it to exponential. All right. Once again, there's not a base by the logarithm. So what is my base? Good job. It is a 10. So I got a 10 raised to the second power. That's going to equal this result of an x squared minus 21x. So y'all, let's do this the next step. What does 10 squared equal? So that's a 100. So I got 100 equals x squared minus 21x. So y'all, here's the thing on this one. You got an x squared on this. This one is quadratic since we got that x squared on it. And we learned to solve quadratic equations, we need everything on one side equal to 0. Okay? So get everything equal to 0. All right, so to do that, I'm going to subtract that 100 from both sides. So I get a 0 equals x squared minus 21x and then minus that 100. That 100 goes to the end now since I moved it over and that was my number. So y'all guess what? I'm going to factor this to solve it. But remember, you can graph it, look for the x-intercepts. That'll give you the two answers. Or you can do the quadratic formula. The negative b plus or minus square root. Have fun doing that, okay? All right, y'all, let's hear. X and an x. Remember, I said if this last number here, if this last number is negative, you're going to have unlike signs for your factors. I also said if this last number is negative, you're going to find factors of 100 that'll subtract and give me 21. So y'all, let's see how many ways we can multiply to get 100. And then I think that's it. So what pair of these factors would subtract and give you that 21? So 4 and 25. Now, y'all, here's the thing. Remember, the larger factor always has the same sign as the middle number. So the 25 will be negative. The 4 would be positive. All right, so I got them set. So let's solve both of those. So y'all, for the first one, I would subtract 4 from both sides and get x equals a negative 4. For the second one, I would add 25 to both sides. And I would get x equals 25. So y'all, what is my final answer on this problem? Oh, I got you, Jesslyn. So y'all let me show y'all something, member. Member over here. Oh, good job, Mackenzie. No negative answers. We got to throw them negative answers out, y'all. So this negative 4, that thing's getting kicked out, and our only answer is going to be that positive 25, okay? So we always got to throw out negative answers because when you put that log negative 4 here, you're going to get an error, okay? So now 25 minus 21 gives me a 4, so I can do that one. Log of 25 gives me a nice number, so I can do that one. All right, so remember that, y'all. Although you're going to get two answers, We're throwing one of them definitely out. Oh, look at this. Number 11's got logs everywhere. All right, I got a log base 3 of t plus 16 minus a log base 3 of t plus 7. All of that's going to equal a log base 3 of a t. So look, we got logs on both sides, but the first thing we got to do, we got two logs on this side, so we got to rewrite these as a single log. Now remember, since they're being subtracted, when I rewrite it, it's going to look like a quotient. So let's bring out that log 3 to the front. The positive factor goes to the top of the fraction. The one being subtracted, that t plus 7 goes to the bottom. And then that's going to equal this log 3 of a t. So look at this. You got a log 3 on this side equal to a log 3 on that side. So at that point, I'm looking at this and saying, my log bases match on each side. So Jessa, this is where you're going to do that m time equals n stuff, right? You got your log bases matching. So now I know that this result equals this result since my log bases match. So I know t plus 16 over t plus 7 is going to equal that t. Now, this kind of problem is why we were teaching y'all how to cross multiply. So what I would do, I'm going to put a 1 on bottom, and I'm going to cross multiply this. Remember, this top gets multiplied by that bottom. So t plus 16 times 1 is t plus 16. That's one side. Now the other side is going to equal this t plus 7. Both of them are going to get multiplied by that t. So t times t is t squared plus 7 times t is 7t. Okay, so that's all you're doing on this one. You're going to cross multiply to get this equation. Guess what? This is quadratic again. So I need a 0 on this side. Just like that last one we just did. Okay? So anytime you got t squared, x squared, you need a 0 on one side. So to get a 0, I'm going to subtract t from both sides. And I'm going to subtract 16 from both sides. Now you can do them one at a time, or you can do them both at once. But this t negative t cancels. 16 negative 16 cancels. Everything cancels, so that side is now a 0. Now over here, I'm going to bring down my t squared. Here you had a 7t. We subtracted a t. So that's going to leave you 6t. And then at the end is a minus 16. And y'all look at that. I got everything on one side equal to 0. So now I'm going to solve mine by factoring. T squared is a t and a t. Once again, the last number is negative. So one factor is positive One factor is negative. All right, let's find factors of 16. 1 and 16, 2 and 8, and what's left? 4 and 4. Remember, I want factors of this 16 that'll subtract and give me 6. So y'all, what are you picking? 8 and 2, good job. So let me ask you this. Which of these two numbers is going to be negative? -2, good job. Because remember, the larger factor, which is 8, has to be the same sign as the middle. So the 8 would be positive. The 2 would be negative. Good job. All right, y'all, the last part, solving both of these by setting them equal to 0. So y'all, looks like the first one, I'm going to subtract 8. I get t equals -8. Second one, I'm going to add 2. And I'm going to get t equals a positive 2. So on this one, what are y'all putting in MATLAB? Oh, gosh, y'all froze, it looks like. What is my final answer? Let me ask it that way. Mackenzie, good job too. Y'all, you gotta kick out that -8 because you can't take the log of a negative number. So your only answer is going to be 2 on that one, okay? No, they're not bad. You just gotta follow them steps, Drew, on these problems, okay? All right, y'all. So what's next? Number 12. And let's see what I got here for 12. I got a log base 4 of x plus 1 minus a log base 4 of x equals 3. Well, I don't have a log on the right side at all, but I do got 2 logs on the left side, and we're going to write these 2 logs as a single log. So write as a single log. And that's always the first thing you want to look at on these logs, okay? So bring out that log 4. So let me ask you, since these are being subtracted, would I rewrite these as a product or a quotient? Good job, Mackenzie. It's going to be a quotient. So the positive factor, the x plus 1 is going to the top. The factor being subtracted, the x is going to the bottom. And that's going to equal that 3. So I don't have a log base equal to a log base on this one. Because I don't even have a log on the right side. So since I don't have a log base equal to a log base, the only other thing I can do is rewrite this as exponential. My base is a 4. My exponent is a 3. And that's going to equal that result of a x plus 1 over x. All right, y'all. So the first thing y'all got to figure out is what is 4 to the third power equal? So that's going to be a 4 times a 4 times a 4. All right, Jason, it's 64. So 64 is going to equal x plus 1 over x. And y'all, at this point, I would put a 1 under the 64, and I'm going to cross multiply. So this 64 multiplies times the x. So that's just going to give me a 64x. That's going to equal the other side, which is a 1 times x plus 1. Well, 1 times x plus 1 is x plus 1. So let's see what we got. So it looks like I got x's over here, x's plus number here. I'm going to get all my x's on this side first. So to do that, we're going to subtract x from both sides. So that's going to give me 63x equals, well, those cancel, so all that's left is a 1. All right, remember this. I want to turn the 63x's into 1x's. So we're going to divide both sides by 63. And that's going to equal this 1 divided by 63. So those cancel, giving me 1x. And y'all, I can't do nothing to that, so I'm going to leave that a 1 over 63. So y'all, really, that's the trick on these, is just to follow through and just see what you can do at each step on them, okay? All right, y'all, I'm going to get another sheet for this one. This one's sort of bigger. Okay, so I was on 13. All right, y'all, a log base 3, x plus 12 plus a log base 3, x minus 12 equals a positive 4. All right, y'all, I got two logs on the left side, so we're going to rewrite these two logs as a single log. So bring out that log 3. But y'all, would I rewrite this one as a product or a quotient? So good job. It's a product because these ones are being added. So that means it's going to be the x plus 12 times the x minus 12. All of this is going to equal that 4. Now, I usually go one more step on these and multiply that out. Now, you can FOIL this on the side if you want to, but y'all, I'm going to tell you a little trick. These are conjugate pairs. You got x plus 12, x minus 12. Anytime you got conjugate pairs, you can shortcut and do x times x, which is x squared. And then 12 times negative 12 is a negative 144. You don't have to FOIL it all out because this 12x on the inside will cancel with that negative 12x on the outside. So when you got conjugate pairs, and that's what these are, conjugate pairs. Conjugate pairs, you can do the first two and then the last two, okay? All this is going to equal that 4. Well, y'all look at this. I don't have a log base equal to a log base. So I'm going to rewrite it as exponential. All righty. I got a base of 3, exponent of 4, and that's going to equal my x squared minus 144. All right, y'all. So what we need to figure out is what 3 to the fourth power equals. What y'all got? 81. Good job. So 81 equals x squared minus 144. So y'all, what I do to these, when I just got numbers and the x squared term, since I don't have the x term in the middle, the way I'm going to solve this is doing the square root stuff. That's how I solve these quadratic equations. So to do that, I would add the 144 to both sides. So that gives me 225 equal to my x squared. Then I'm going to do square roots to both sides. All right, so the square root of a number will be a plus or minus. All right, y'all, what is the square root of 225? So that's going to be 15. So I get a plus or minus 15 equal to my x. So that means this is x equals 15, x equals negative 15. Good job. What's the final answer? What you got there? 15? Yeah, because once again, I'm going to kick out that negative answer and only keep my positive answer, okay? Oh, and y'all, I think I got offline here. I'll do 13. This one's 14, actually. This was actually 14. I got offline here. So I'll do 13 next, okay? So somehow I was looking at the right side instead of my left side of my paper. So remember, this one will be like your number 14 here, and the one I'm about to do will be like your number 13. All right, so 13 is this one. Log 3 of x plus log 3 x minus 1 is going to equal a log 3 of 6. So your 13 actually had logs on both sides, okay? But you're going to start out writing the left side as a single log. And since they're being added, we'll do this as a product. So bring out that log 3, and it'll be x times x minus 1. That's going to equal the right side, which is a log base 3 of a 6. Y'all, anytime I got a product, I go on and multiply that stuff out so that I get a log 3. X times x is x squared minus x times 1 is 1x. All that equal to a log 3 of 6. But look at this one. You got log bases that match on each side. So your log bases match. So we're going to rewrite it using the logarithmic equality, which says if I got a log base on either side of the equals that is the same, then that means the x squared minus x has to equal the 6. Y'all look at this. This is quadratic again. So what I need a 0 over here. Now remember, the one where I did square roots a while ago was because it didn't have an x term. This one does have the x term. So I want everything on one side equal to 0. And y'all, to do that, you're going to subtract 6 from both sides. So you get an x squared minus x minus 6 equal to 0. And we're going to factor that. X squared is an x and an x. The last one's negative again, so you got a positive and a negative. All right, y'all, let's find factors of 6. We got 1 and 6 and 2 and 3. I need mine to subtract and give me a 1. So, y'all, that's going to be 3 and 2. The larger number is going to be negative like the middle, and then the 2 will be positive. All right, y'all, let's finish it out. Set both these equal to 0. Solve this one by subtracting 2. I'm going to get x is a negative 2. I'm going to solve this one by adding 3 and get x equals a positive 3. Once again, I'm not going to keep that negative answer, and the only answer is a positive 3. So, y'all, any questions over those um, equations? All right, so y'all look good. Um, so y'all take a, let me quit sharing. Let's take a little break. It's 11:13. So how about we come back at 11:20? 11:20, we'll knock out the 9.7. It's not as long as the equations, okay? So I'm going to pause my recording and we'll get started on 9.7. All right, this is applications, and they deal with growth and decay. So growth can be an investment growing, it can be the population growing, um, and things like that, okay? So new formulas. So for growth, our formula is going to be P of T, and y'all all explain everything as we go. P subscript O times E raised to the K times T. So let me explain everything. P of T is the population at any time T or the investment at any time T. So the population or investment at any time T. So if I know how many years going by, I can plug it into my formula and then find my answers, okay? So this P sub O here, P sub O is the initial population or amount of the investment. Okay, so that's what this P sub O is. O stands for the initial amount. E, well, that's Euler's number. And we've been looking at it all chapter, right? So what is K? K is the growth rate or the interest rate. And once again, that has to be in decimal form when we put it in a formula. And y'all, T is still time in years. So if I got continuous compounding, which means it's always being compounded, then we would use this formula for our investments, okay? Now, The only difference is if it was decay, if I was looking for decay, which would be a decline in the population and stuff like that, then this K would be negative. Okay. So the K is negative for decay. It's positive for your growth. All right. So some other formulas we'll see in here in this section. We got a formula for what we call the double time. Double time is the amount of time it takes for your population to double or your investment to double. So say I invested $5,000 at a continuous interest rate of 5%, then the double time would be the amount of time it takes for my 5,000 to turn into a 10,000, okay? And that formula has a capital T, which stands for double time. That's going to equal the ln of 2 divided by K. So T, when it's capital, is double time. And y'all, K is still my growth rate. It's got to be in decimal form in here, okay? All right. Now, what if I want a formula to find K, my constant? So if they give me all this information and they want me to find K, I would use this following formula. K equals the ln of P of T divided by P of O, all of that over the time. So it's the P of T divided by P of O, the ln of that, and then we divide by the time. And y'all, one more formula. What if I was looking for T? So what if they wanted me to find T? How many years would it take for my population or investment to go from one amount to another? If I'm looking for that kind of time, then my formula is going to equal T equals the ln of your P of T divided by P initial all over K. So look, you want K, you divide by T. You want T, you divide by K on this, okay? So keep these formulas close by because that's what we're going to use in this section, okay? All right, y'all, so let's play with some of these. Number one says, in 2012, the population of a city was 5.21 million. Exponential growth rate was 1.56% per year. All right, so they got a part A. Part A, they want me to find the exponential growth function. So this is just the formula we would use in this situation. So they're going to give you the P of T, and then we're going to put in the formula. All right, so remember, it started out with P sub O, my initial amount. My initial amount is 5.21 million. So that's going to be 5.21. And then we had E. And then that's raised to the KT. Well, y'all look here. K is 1.56%. I need to turn that into decimal form. So remember, to turn it into decimal form, you got to move the decimal left twice. So that means I got to add a zero on this one and get a 0.0156. You got to change these percents into a decimal. So that'll be 0.0156 times t. So if I want to know if I knew how many years passed, I could plug that in for t, work this formula, and get my population. But y'all, for this one, this is all MathLab wanted, was us to figure out what formula we would use. So part B, they want to know, estimate the population in 2018. So we got to figure out what t equals. Well, it's going to be the 2018 minus 2012. So that means t is going to be 6 years for us. So you got to figure out how many years from 2012 you're looking at. So that means t is 6. So we're finding p of 6. So p of 6 is going to equal 5.21 times e to the 0.0156 times 6 years. All right, y'all. So I'm going to push that in on my calculator. And let's see. They want me to round it 1 decimal place. So 4.8, 5.9, something like that, okay? So we're rounding it 1 decimal place. So let's clear everything. All right, so I had 5.21. So 5.21. Now, since I'm using e with an exponent, I'm going to hit second ln to get e with the exponent. And I had 0.0156 times 6 years. Now, since it's growth, we better get more than 5.21 million on this, right? So when I hit enter, I get 5.72. Rounding that 1 decimal place, that's going to be 5.7. Now, all we do is put in the 5.7. MathLab already has the million there. So they went up about a half a million from 5.21 to 5.7 in 6 years. So for C, the population will be 9 million in about blank years. After 2012. So how many years is it going to take for this population to reach 9 million? So y'all, this goes back, since you're looking for time, you're going to use the formula that I had for time, which was the ln of your p of t divided by p initial over your k. All right, so that's going to be ln P of T, I know that. That's going to be 9 million because that's going to be the ending amount. So the ending amount is what P of T is. So that's going to be the 9 million. So they're giving you the ending amount, which is always the P of T. P of O is the initial amount. Well, you always started with the 5.21 million. So we'll take this ln of this ratio here and divide by k. Well, we figured out k up here was 0.0156. Now, y'all, let me see on this one. They want me to round one decimal place. So let me show you how I would do this one. All right, I'm going to clear my calculator off so you can watch my steps. First of all, I'm going to make it look like a fraction by hitting alpha y equals enter. Now on the top, I'm doing an ln, and this is the ln of a fraction, so I'm going to hit alpha y equals and enter. Okay, yeah, that'll work, Jesslyn. Okay, so on top I had a 9. On bottom I had a 5.21. And then I'm going to close those parentheses. And then I'm going to arrow down to the bottom and put in my 0.0156. Okay, so you got to use the main fraction. And then when you do the ln, hit the fraction again to get that 9 over 5.21. All right, I'm rounding this one decimal place. So when I hit enter, I get 35.04. So y'all, that's just going to be what, a 35.0. Since there's a 4 after, that's going to be 35.0. If that had been a 5 or greater, then I'd have made that a 0.1, okay? Alrighty, y'all. So it's going to be about 35.0 years after 2012. All right, y'all. Then let me see what D wants. So after D, I'll let y'all write them formulas down, okay? So the doubling time is about blank years. Remember, doubling time is the amount of time it takes for this 5.121 to double and be 10.42. Okay. Now I know to get to 9 million, it took 35 years. And we're even bigger than that to double that. So we better get something bigger than 35 years. So remember, that formula is T equals the ln of 2 divided by K. So that's going to be ln of 2 divided by K, which was 0.0156. So y'all, let's punch that in. Ln of 2 divided by 0.0156. And I'm going to make that look like a fraction. Alpha, y equals, and enter. On top was an ln of 2, close parentheses. On bottom was my K, 0.0156. Now let's see, they want us to round this one decimal place. So y'all remember, it's got to be bigger than 35, and look at that. 44.4, because we'll keep that a 4 because it had a 3 after it. So 44.4 years. And then on that one, MathLab would have the years. You're just putting in the 35.0. And then y'all, this one would have years also. Okay, so we're going to be using those formulas that I gave y'all. So y'all, let me go back to the formula sheet and let y'all write these formulas down. So this one finds the population at any time t, your initial population times e raised to the kt K was growth rate, T was time. To find the straight up double time, the amount it takes your investment to double or population, that's capital T equals the ln of 2 divided by K. If I want to find K, I can use this formula. K equals the ln of P of T divided by P of O, all of that over T. And then here was to find T. If you want to know the time, then you would use T equals the ln of your PT divided by PO, all divided by K. Now, y'all, I'll tell you another one. If you know the double time, there's another way to find K. If you know the double time, then you can find the K by doing the ln of 2 divided by the double time, okay? So down here, K is if you don't know the double time, but you know everything else. Because y'all, pretty soon, my next one, they're going to actually give us a chart and we're going to fill it in. Hey, y'all, so let me know when y'all are done getting these formulas because these are really the ones we're going to be using, okay? Okay, so y'all got it? All right. Oh, my page is always curl. All righty. For this number 2, we're going to complete the table. So on this top table, they got population in the first column, and they got country A and country B. The next column is the growth rate, K. Now, on the growth rate for K, A has 1.9% per year, and country B has a box there. So we're going to find country B's growth rate in a second. Now, over here, they got the doubling time. Capital T. So this one, they got a blank and then years. And then this one has 43 years. So I know country A's growth rate, but not its doubling time. I know country B's doubling time, but not their growth rate. They want me to fill in these 2 boxes, okay? So the first thing I'm going to find is the doubling time for country A. So that's going to be a capital T. And then I use, this is doubling time, and I'm putting the A here to represent the doubling time of A here, okay? That equaled ln of 2 divided by its K. So y'all, that'll be ln of 2. Now look here. The K for country A is 1.9%. So y'all turn that 1.9% into a decimal for me. What would I use as my decimal form? Well, y'all got 0.019, perfect. Remember, you're moving that decimal twice to the left. All right, y'all, let's see. On doubling time, it looks like we're just going to do like they did and do it one decimal place when we're done, okay? And let me see. Oh, I'm doing doubling time for A. And it looks like they're rounding off to the nearest years. So we're going to round ours off to the nearest year, okay? So let's take that ln of 2 and divide by that 0.019. So alpha y equals enter. On top, I got an ln of 2 close parentheses, and then that was 0.019. All right, y'all, we're going to round it to the nearest year. So I got 36.4. So y'all, that looks like 36 on that one, okay? All right, so it'll be 36 years for that one to double. So I had 36.4814, but remember, since that was a 4 or less, we need that at 36. So you'd put 36 into that blank. Now, this one, they want me to find the growth rate of country B. So that'll be the K of country B. That's going to equal to ln of 2 over the double time for that one. We want the double time of B. So the ln of 2, double time for B was 43 years. So bring in that 43. All righty, y'all. So let's get this into calculator real quick. So alpha y equals enter. On top was a ln of 2. On bottom was 43 years for double time. I'm going to hit enter, and I get a 0.0161. I'll just go out a few decimals for the moment. All right, but let me show you what you're going to do. We need to go back to percent. So to go back to percent, you're going to move the decimal right 2 units, and I get a 1.61. But y'all notice, they're only going one decimal place. So this 1.61, I'm going to make that a 1.6. So you'll put 1.6 in the blank, and they've already got the percentage. So convert it from a decimal to a percent. At this point, this is all percent, okay? And when you get your percent, you got to round it one decimal place. So that's why I went a few numbers out to do that, okay? So that's what you're doing for completing the table. All righty, the next one will be an investment problem. So here we go. So y'all suppose $10,346 is invested at 5.1% per year, compounded continuously. All right, so compounded continuously for A. Find the exponential growth function. So basically, we got to find the so the exponential growth function will be P of T equals. So what would I put here for P of O? What is y'all's starting amount? Well, y'all, they gave that to us, right? They said your starting amount was what? 10,346. Then we got E. All right, y'all, I need my K. K was my interest rate, but y'all need to put my interest rate into decimal form. So y'all need to turn that 5.1% into a decimal. Oh, I think Jason, I think you got one too many. Remember, 5.1, move it left twice. So we're just going to add 1 0. Perfect. That'll be a 0.051 times T. So this is the formula they want in Math Lab. And this is the formula we can use to find anything else. All right, so let's see. They want us to find what is the balance after T equals 1, 2, 5, and 10 years. So they want to know the balance after all these years. So when T equals 1, I'll have a balance. T equals 2, I'll have a higher balance, I hope. T equals 5, and then T equals 10. So basically, this formula, they want me to put a 1 in for the T. And then they want me to put a 2 in and so on, okay? Now on this one, we're rounding to the nearest cents. So you got to have 2 decimal places, okay? Hey, y'all, so I'm just going to do mine one by one. 10,346. Second ln to get the e with the exponent. And then that was 0.051 times 1 year. So that one looks like 10,887.33. So since my second 3 had a 2 after it, I'm leaving it the same. Then I would do 10, 3, 4, 6, second ln, and then I got 0.051 times 2 years. When I hit enter, notice my money's going up, so that's what you want. 11,456.98, but my 8 has a 9 after it, so I'm going to make that a 0.99. All right, then I got 5 years, so 10,346. Second ln to get the e, and then it's a 0.051 times 5 years. So it better be going up still. So when I hit enter, I get 13,351 point, and y'all look at that. I got a 1, 1, but my second one has a 5 after it. So we're going to make that a 0.12 on that one. And y'all finally was 10 years. So 10,346, second ln, and then the exponent is 0.051 times 10 years. So the money better keep going up. And when I hit enter, we're at 17,229 point, and let's see, that's a 1 0. The 0 has a 2 after it, so I'm going to leave that as 0. So that'll be a 0.10. Okay, that's all you're doing. Punch in a 1 in that T, a 2 into T, a 5 into T, and then a T for the T. All right, y'all, the last thing they want to know, the doubling time is blank years. How long is it going to take my $10,346 to double? So doubling time was capital T equals the ln of 2 divided by RK. Well, we got K up there. That was at 0.051. So this will be the ln of 2 divided by 0.051. Hey, y'all, so that's all we got to do on that one. Um, I know it'll be more than 10 years because at 10 years, my money went from 10,000 to 17,000 and something. So this is going to be a little more. So alpha y equals enter for my fraction. On top is ln of 2, close parentheses. On bottom, k was a 0.051. When I hit enter, let me see what they want me to round this one off to. Um, they're going one decimal place on this one. So when I hit enter, I get 13.59. So I'm going to change that 5 into a 6, and that's going to be 13.6. And y'all, that makes sense. In 10 years, it went from 10,000 to 17,000. So another 3.5 years or so, it's going to go from that 17,000 into 20,700 or whatever, okay? So in the blank, all you had to put was this, 13.6. All righty, y'all. So we got one more question, and check this out. It's not even a bad one. And this question right here is one that's like on my final exam. So put a little star by number 4 here. Because number 4 is a question just like on my final exam, okay? Oh, y'all, let me go. Let me find something real quick. I'm going to try to get a question just like they got in here. Also, they changed it. So, okay, so that's what I was thinking. They always changing stuff up. All right, y'all. So here we go. So for this number 4, um, they're currently, and you don't have to start, they changed it up. So this one ain't the one like the final. Um, there are currently 58 million cars in a certain country, decreasing by 6.1% annually. How many years will it take for the country to have 37 million cars. And we're going to round it to the nearest year. So this one, I'm only looking for time on this one. Okay? But y'all remember this one. This one is decreasing. So since it's decreasing, my K will be negative when I punch it in there, okay? I'm going to change this to a decimal and then make it negative. Now we're only looking for the time, right? How much time, how many years? So we're going to use this formula right here where I had it solved for T. All right, so T equaled the ln of my P of T over my P initial, all divided by a negative K. The negative is always in the formula when you're decreasing like this one, okay? So let's put everything in. ln, P of T was the final amount. So they want to know the final amount was 37 million. So the final amount will be less than the starting amount when you're going down, okay? The starting amount was the 58 million. All of this will be divided by our K. And remember, K will be negative. So y'all, what I need y'all to do is turn the 6.1% into a decimal. I want to see what y'all are putting in for that. Hey, what do y'all got? 0.061 sounds good. But y'all remember that's a negative 0.061, okay? Because what's going to happen when you do an ln of a smaller number divided by a larger number, you're going to get a negative number here, and that negative divided by negative will make your time positive, okay? So y'all, let's go punch that in. I'm going to clear everything off. So first I want a fraction, alpha y equals inner. On the top, I got the ln, and I got another fraction, so I'm going to hit alpha y equals inner. On that one, I had 37 on top. On the bottom, I had 58. I'm going to arrow right, close those parentheses. On the bottom, I got a negative 0.061. Oh, y'all, when we hit enter, and we're rounding at one decimal place, remember, I get 7.36. So I'm going to make that a 7.4. Alrighty, y'all, so we would go back and we would put in a 7.4. Math Lab will have the years. Okay, so 7.4 years for them to go from 58 million down to 37 million, okay? All right, y'all, so questions. Anyone got any questions on this today? So you got 4 problems in the homework, okay? It'll be the population one, then the one where you had the little chart, then you had the investment one, and then this one about the decreasing, okay? All right, y'all, this is the last new material you're getting all year was this 9.7, okay? So So Mackenzie for 9.6, I gave everybody a 10 on that homework because we did cross multiplying last week. And since we already did cross multiplying last week and we went over it today, I just gave everybody 10s on 9.6 and let it go, okay?
Mm.
um, so y'all catch up tomorrow. We're reviewing for test four, and you're going to knock out test four pretty quick this week because Wednesday we're reviewing for the final exam, and y'all's final exam is Thursday, okay? So everything has to be done by Thursday night. Um, if y'all are good and you want to go ahead and do your test, knock it out. I cannot open the final exam until Wednesday, though, okay? Um, I'm reviewing for test four tomorrow, Jesslyn. And then Wednesday, I'm reviewing for the final exam. And then what I'll do, we really won't have class Thursday since it's your final exam, but I will be online for y'all if you have any questions and stuff. So Thursday will be, if you need me, then you get online and we'll do that kind of stuff. So what does this say? Yeah, so try to finish everything. Now you don't have to do the test tonight, Amani. You can wait till tomorrow night to do the test four if you want to wait until after we review.